Dear students, welcome to revision class of Unit 1 Mechanics. On examination point of view, I would like to discuss some important concepts. First, I will start with the physical quantity. In physics, we deal with measurable quantities. Physical quantities can be measured in definite terms and it is possible to get mathematical relation between them. Here, any quantity which can be measured in terms of numerical value is called physical quantity. Example, length, mass, time, volume, speed, etc. Here, physical quantities are classified into two types. The first one is the fundamental physical quantity, second one is the derived physical quantity. The fundamental physical quantity are independent of each other and they cannot be derived from one another. Example, length, mass and time. The physical quantities which are derived from one or more fundamental physical quantities are called derived physical quantities. They can be derived from one another. Example, area, volume, speed, velocity, acceleration, etc. Next one is the unit. Unit is the standard of reference is used to express a physical quantity. Here, unit can be classified into two groups. One is fundamental units, second one is the derived units. Fundamental units. Units of fundamental physical quantities are called fundamental units. Example, the unit of length, the unit of mass, the unit of time. Here the unit of length is meter, the unit of mass is kilogram and the unit of time is second. The derived units, the units of physical quantities which are derived from the fundamental units are called derived units. There are some basic units and supplementary units in SI. SI is the abbreviation of System of International D units in French. This system was developed and recommended by 11th General Conference of Weight and Measures in 1960. This system is widely used in all scientific measurements throughout the world. There are 7 basic units. The basic quantity and their units. The basic quantity is length and their unit is meter. The basic quantity is mass and their unit is kilogram. The basic quantity is time and their unit is second. Electric current, their unit is ampere. Temperature, their unit is Kelvin. Luminous intensity, their unit is candela. Amount of substance, the unit is mole. There are two supplementary units. One is plane angle, their unit is radian. Second one is the solid angle, their unit is steradian. Next one is the advantages of SI. Here there are 4 advantages of SI. The first one is it is the rationalized system of units because only one unit is used for one physical quantity. Example, joule is used as unit of energy for all types of energies. Second one is it is the comprehensive system of units because 7 fundamental units and 2 supplementary units cover all branches of science and engineering. The third one is it is the coherent system of units because all derived units can be obtained by suitable manipulation of basic and supplementary units and no numerical factors are encountered. And the last one is the metric system like CGS and MKS because multiples and submultiples can be expressed as the powers of 10. The next one is the measuring instrument. Here already we know that physics is known as a science of accurate measurement. Here the comparison of a physical quantity with a standard quantity is called measurement. For better accuracy we can measure the length, diameter and thickness by different instruments. For more accuracy we can use to measure the length vernier calipers and screw gauge. Here least count is the smallest length that can be accurately measured by an instrument is called least count of the instrument. Next one is the vernier calipers. Here the vernier scale was designed by Perry Vernier in 1630. Here vernier is a secondary scale used along with the main scale. Vernier slides along the main scale. It is used for measuring length accurately to any desired fraction of a smallest division on the main scale. Here vernier calipers consist of the upper jaws, lower jaws, screw, vernier scale, main scale and depth bar. Next one is the pitch. The distance between two consecutive threads of the screw is called pitch. Here screw gauge works on the principle of nut and screw. Here screw gauge consists of the U-shaped frame, or we can call it as C-shaped frame, and anvil tip, spindle, screw nut or lock nut, sleeve, thimble and ratchet. Here spindle is attached with the thimble and spindle is rotated by using ratchet. Here the screw gauge consists of pitch scale and head scale. Next one is the resultant. Here resultant is a force which produces the same effect as the combined effect of two or more forces acting on a body simultaneously. Equilibrant. An equilibrant is a force applied on a body which is acted upon by a number of forces to keep it in equilibrium. Here resultant is always equal and opposite to the resultant. Therefore the relation between them we can write it as resultant is equal to minus equilibrant. Next one is the expression for the magnitude and direction of the resultant of two vectors acting at a point. Here we have to consider the two forces P and Q be represented both in magnitude and direction by OA and OB respectively. Here complete the parallelogram OACB and join OC. Here OC represents the resultant of P and Q. Draw CD perpendicular to OA produced. Since AC and OB are parallel and equal, AC also represents the force Q. Let angle BOA is equal to theta and angle COA is equal to alpha. In the right angle triangle ADC, AD by AC is equal to cos theta, or AD is equal to AC cos theta, that is equal to Q cos theta. And CD by AC is equal to sin theta, or CD is equal to AC sin theta, that equal to Q sin theta. Herein we consider the right angle triangle OCD. In the right angle triangle OCD, OC square is equal to OA square, OC square is equal to OD square plus CD square according to Pythagoras theorem. Here OD square is equal to OA plus AD. Therefore OA plus AD square, it is in the form of A plus B whole square. Therefore A plus B whole square is equal to A square plus B square plus 2AB. Therefore OC square is equal to OA square plus AD square plus 2OA into AD plus CD square. Here putting the values of OA, OC, R and AD and CD, we get R square is equal to P square plus 2PQ cos theta plus Q square cos square theta plus q square sin square theta. Here r square is equal to p square plus q square into cos square theta plus sin square theta plus 2pq cos theta. Here cos square theta plus sin square theta is 1. Therefore, r square is equal to p square plus q square plus 2pq cos theta. This equation gives magnitude of the resultant, or we can write r is equal to square root of p square plus q square plus 2pq cos theta. Next one is the movement of a force. Here the ability of a force to rotate the body about a fixed point is called movement of a force, or the turning effect of the force is also called movement of the force. There are two movements. One is positive movement, second one is the negative movement. Movements which tends to produce rotation in an anti-clockwise directions are conventionally taken as positive movement, and the movements which tends to produce rotation in an clockwise direction are conventionally taken as negative movement. There are two conditions of the equilibrium of coplanar parallel forces. The first condition is sum of the forces in one direction is equal to the sum of the forces in the opposite direction, or the algebraic sum of the forces acting on a body must be 0. Second condition is that the sum of the anti-clockwise movements must be equal to sum of clockwise movement, or sum of positive movements is equal to sum of negative movements. Next one is the statement of law of parallelogram of forces. Here, if we consider the two forces acting at a point are represented both in magnitude and direction by the two adjacent sides of a parallelogram, then the diagonal of the parallelogram represents the resultant both in magnitude and direction. The second one is the converse law of triangle of force. Here, if three forces acting at a point are in equilibrium, then they can be represented by both in magnitude and direction by three sides of a triangle taken in order. The last one is the Lami's theorem. Here Lami's theorem states that if three forces acting at a point are in equilibrium, then each force is directly proportional to the sine of the angle between the other two forces. Or we can define it as if three forces acting at a point are in equilibrium, then each force is directly proportional to sine of the opposite angle, or each force is directly proportional to sine of the angle between the two forces. Thank you.